Welcome to the Minnesota Stormwater Seminar Series, co-sponsored by the Water Resources Center and the San Antonio Falls Laboratory, both at the University of Minnesota. I am John Gulliver, and I will introduce our speaker. We are very happy to have Jane Clary give today's talk. Jane is a Vice President and Senior Water Resources Scientist of Wright Water Engineers in Denver, Colorado. She has worked on stormwater best management practices, water conservation, water quality, and related regulatory issues for 24 years. Jane is a product manager of the International Stormwater BMP Database, which many of you have used or know about, and was named the Green Co. 2008 Person of the Year for her work in landscape water conservation for the green industries of Colorado. Jane has literally written the book on pathogens and stormwater runoff, having been an organizer and the primary author on pathogens in urban stormwater systems, which is 267 pages of desperately needed information, published by the American Society of Civil Engineers in 2014. She recently completed a term as Commissioner of the Colorado Water Quality Control Commission and has been named a Fellow of the American Society of Civil Engineers. Today, Jane will be talking about pathogens and related management tools. So it is my pleasure to welcome Jane Clary.
So, can everyone hear me all right? I think I'm good to go here. Well, I'm really excited to participate in the webinar today, and I wish that circumstances were different and that I could be there in person, and I'm really looking forward to the panel discussion after my presentation. This is a topic that has been of significant interest to me for about 20 years now. I serve as a watershed coordinator for a watershed just north of Denver. And we have been dealing with elevated E. coli in our stream and an E. coli TMDL. And so probably like many of you, we've been working through what the sources are. You know, are the sources the birds under bridges like this, or is it something that's more infrastructure related? So for our talk today, I struggled with how many topics we could fit in the next 35 to 40 minutes, and kind of landed on trying to cover 4 areas. First, we'll focus on an introduction to fecal indicator bacteria, or FIB. You'll see that on some of my slides, and pathogen issues. And second topic is we'll speedily go through some resources for municipal stormwater managers. Third, we'll focus on stormwater BMP performance in the International Stormwater BMP Database. And I'm going to use the term BMP for best management practices. This is synonymous with stormwater control measure, or SEM, but I will use the term BMP. And then fourth, we'll touch on some research needs and some unresolved policy issues. And I guess just as a bit of personal background, I would say that I am that mom that embarrasses her children by taking pictures of scenes like this, and a no swimming sign in Hawaii, and duck poo on our neighborhood pond. So this is a topic that I follow with great interest. And I think just to make sure we're all on the same page as we're talking about this topic, you know, E. coli is in the news with a big hamburger recall that's going on right now that's due to a specific pathogenic strain of E. coli 0157H7. But when we're talking about E. coli today, we're talking about fecal indicator bacteria, which are not necessarily disease-causing. They're used as indicators of potential pathogens. So I just wanted to make sure we're on the same page there. Also, just as a basic starting point in terms of recreational water quality criteria, the recreational water quality criteria around the country do vary a bit. And so as kind of a common starting place, I wanted to introduce EPA's 2012 recreational water quality criteria. And EPA provides several different options there in terms of indicators and allowable illness rates. And the one that I'm going to be talking from primarily, which is the one that's mostly implemented in Minnesota and also in Colorado, is the E. coli freshwater standard that is associated with an allowable illness rate or gastrointestinal illness rate of 36 illnesses per 1,000 exposures. And the standard is based on a geometric mean concentration of 126 colony forming units per 100 milliliters, and no exceedances of that geometric mean concentration are allowed. And the assessment period recommended by EPA is a 30-day period, but there is some variation among different states as to whether it's a 60-day period or a seasonal period or some other period, but those are kind of the key points there. Additionally, some states incorporate a single sample maximum, or EPA currently recommends a statistical threshold value for an upper limit, but we're not going to talk about that part of the standard today just because there's a lot of variation in that. The other thing that I wanted to mention that was something relevant to EPA's 2012 recreational water quality criteria is that EPA no longer recommends differing standards for varying use intensities. And so if you look at the pictures on the right here, these are some streams in Colorado where children are wading shallow water versus swimming in a river, and the same stream standard would apply to both of those due to potential ingestion of water. One unique aspect of the new aspect, I guess, of the 2012 recreational water quality criteria is that EPA did recognize that there are differing risks for illness depending on what the source of the fecal indicator bacteria are. However, they weren't able to incorporate that information at a national scale as part of the standard recommendations, but they did open the door to a couple of different options for establishing different stream standards. And those options are epidemiological studies, quantitative microbial risk assessment or QMRA, and alternative indicators or methods. And I'm not going to get into these today because this would be a discussion all to itself, but the QMRA incorporates, I did want to mention that it's focused on recreational exposure and looks at a couple of key pathogens, which are norovirus, Cryptosporidium giardia, Campylobacter salmonella, and E. coli 0157H7. And so again, this is the differentiation between fecal indicator bacteria and pathogens, and you do need pathogen data to do QMRA. This graph over here on the right, you've probably seen in many presentations on this topic, but the bottom line here is that some of the QMRA work that was done at the time that EPA was developing these 2012 criteria showed that risks from sources like gulls and chickens, basically birds, has lower human health risk than sources like human sources of sanitary sources and cattle. So that's kind of the big picture background. If you are a municipal stormwater manager, you probably know what the problem is with E. coli, but I wanted to kind of hit 10 general topics that we've looked at here in Colorado with the Colorado Stormwater Council. And just 10 points here. First of all, recreating in waters with fecal contamination can make you sick, or it can make your citizens sick. So it's a high priority human health issue in terms of total maximum daily load development, or TMDL development. Nationally, it's a huge regulatory issue. There are over 187,000 stream miles listed as impaired or threatened for FIB nationally. It's easy to exceed the E. coli standard or other fecal indicator bacteria standard, particularly in the summer if you're in Colorado or Minnesota. And interpretation of monitoring data can be difficult or inconclusive. There's lots of variability in data sets, and you can just bang your head against the wall trying to find a trend or understand what's going on. Number 5, we don't live in a sterile environment. E. coli can originate from both natural and human sources. And as I mentioned previously, the health risk from those sources can vary. Number 6, solutions cross multiple disciplines and local government departments. So say unlike a total phosphorus issue or a TSS issue, When you're dealing with E. coli, you're probably going to have to reach out to some entities that maybe you don't normally work with. Number 7, finding the sources can be challenging and it can be expensive. And then the source may not be controllable. And here's my doggy diaper picture, which is definitely not a winning strategy there. And number 8, treating dry and wet weather runoff can be challenging and expensive. And number 9, in urban areas, there may not be a silver bullet that solves the problem. There are probably actions that you can take to improve human health and to reduce bacteria loading, but you may not be able to get down to the stream standard, which is point number 10. Just outstanding questions are, can stream standards be consistently attained? And if so, how do we get there? And for MS4 managers, I think that have permit requirements driven by TMDLs, what are the implications if we don't get there? Additionally, some common challenges with E. coli TMDLs and implementation plans is sometimes at the time of TMDL development, there may not be adequate data for development of a meaningful TMDL, but your regulator may be under pressure to complete that TMDL, maybe by an environmental group or other pressures. And so sometimes a TMDL might have, the starting place that you're working with may have, you might start off going in the wrong direction due to, seasonally imbalanced data sets or limited data sets. Maybe there are assumptions about what the problem is, and that may not really be the problem. Maybe there are assumptions about the solutions or very prescriptive actions that are included that may not be, might set you in the wrong direction. And then some of the other challenges that I've experienced working with local governments is sometimes there have been E. coli studies done over the years and data gets lost, or maybe you have E. coli data but you don't have any metadata related to flow conditions or other conditions going on in the watershed, and then just the challenges of coordinating among multiple departments. So that's our introduction there. And so now I'm going to shift over to our next topic, which is some selected resources for MS4s. And as John Gulliver mentioned, in 2014, the Urban Water Resources Research Council had a committee that put together a book called Pathogens in Urban Stormwater Systems. And as I was preparing for this webinar today, I went back to the book to see, how are we still up to date on the information that we included there. And I was kind of pleasantly surprised to realize that really most of what we had there is still right on, maybe missing a few more, recent epidemiological studies and some recent research, but the core of this book is solid, and it's a free download here. And so it's a good resource if you want to get a broad understanding of the issues that MS4s face related to pathogens in urban stormwater systems or fecal indicator bacteria challenges. And the content here is your basic regulatory background, kind of a condensed version of EPA's 2012 criteria, information on sources of bacteria in urban areas, predicting fate and transport and difficulties associated with modeling, monitoring and source tracking. We have a great chapter on statistical analysis that Bob Pitt wrote, information on source controls and structural controls, and then a handful of case studies that really get at the high cost of implementing TMDLs in urban watersheds. And then we hit some research needs as well. In 2016, we created kind of a local version, a simpler version of this book. It's a Colorado E. coli toolbox that was targeted to regulatory issues in Colorado, but again, focused on finding sources, source tracking strategies, developing a control strategy, again, source control and structural BMPs, regulatory flexibilities. And after we completed this, some of our Colorado Stormwater Council members said, really what we need is some easily digestible fact sheets that we can use to communicate with our citizens, with our city councils, across our city departments. And so there's a series of fact sheets there, regulatory summaries, microbial source tracking techniques, and those could include anything from CCTV to using molecular methods like the HF183 human DNA marker. And we have a fact sheet on how to use GIS as part of a source identification study or a sanitary investigation in watersheds, so that when you sit down with your GIS department, you can kind of give them a list of these are the different shapefiles and layers that we want to pull together to shape and form hypotheses for our studies. And then lastly, a fact sheet on BMP performance. And all of these are available from udfcd.org. This is the Mile High Flood District in Denver who sponsored this study. Some other resources that I found to be really valuable is the cutting edge work that's been done in Southern California. And a couple of resources here that I wanted to point out is a brand new one that was just completed in February 2020. And it's a comprehensive human waste source reduction strategy work plan. There's been a shift in California from some of the very expensive TMDL implementation plans, or I believe they're called water quality implementation plans in California, from focusing on very expensive green infrastructure plans that target stormwater generally, to shifting the focus first to identifying human sources of waste and prioritizing those first. And so this is a really great document if you don't have that. John Griffith and others in SQURF have also provided some great guidance on source identification in a few different manuals here. And then, of course, other sources include EPA's guidance, Center for Watershed Protection. There are a variety of different sources out there. But I think what you'll find across these sources is some common themes of the importance of identifying sources of bacteria so that you can target the solutions to the sources, and then focusing first on human sources of bacteria, which are most likely to cause human health issues, and then going to other sources, addressing dry weather sources first because those are going to be the most controllable, then wet weather, implementing non-structural and source controls first, and then structural controls. And really the sweet spot that we're looking for in these strategies are practices that are effective, that are feasible, that are sustainable, and that are cost effective. And you know, the truth is, for dry weather flows, you could put UV disinfection on every stormwater outfall in theory, but that is not a sustainable approach, even though it is effective. And then I also want to just clarify that I'm not in any way saying that we don't need to implement stormwater management with multi-pollutant objectives in our watersheds. We definitely need to be doing that. Just in terms of E. coli strategies, I think the starting place is dry weather. Partners are really important for developing effective control strategies. So if you're a MS4 manager, I think thinking out of the box, thinking about partnering with coalitions for the homeless, partnering with your open space and parks departments, maybe your state wildlife agencies. It's kind of a different approach here than what might be used for, say, sediment or nutrients. So the third area of the talk today is wanted to shift to stormwater BMP performance, and that's where I'm going to spend most of the rest of our time today. As Dr. Gulliver mentioned, I've been involved with the International Stormwater BMP Database Project for about over 20 years now, working with folks like John Jones at Wright Water, Eric Strecker, Mark Leisenring, Paul Hobson at Geosyntec Consultants, Jeff Mueller and Harry Zhang at the Water Research Foundation. And this project has enabled compilation of BMP performance data for over 700 stormwater BMPs. And so that's going to be the basis of our discussion today. So if you've visited the Stormwater BMP Database website 5 years ago, there have been a lot of changes since then. I think we've made a lot of improvements and streamlining of tools, and we update our performance reports pretty regularly. And so today I want to just give you a little overview of how you can access BMP performance data from the BMP database. There are kind of three different levels of ways to access information. First is, I would call it the we do it for you approach, which is our BMP category summary statistics document, and that's updated every 2 to 3 years. And we're in the process of peer review of our 2020 summary statistics, so that'll be coming out soon. The second option is online data retrieval and statistic analysis tools, and we'll go through some examples of those today. There's an option there that I think is very user-friendly. It's a downloadable CSV file where you can basically get an Excel type file and run your own analysis for pollutants of interest to you. And then the third option is really oriented more to more hardcore researchers that want to download a Microsoft Access database and run their own analysis. So I'm only going to be talking about fecal indicator bacteria today, but this table 1 here gives you a list of the pollutants that we include in the analysis, and the table to the right gives you a list of the different BMP categories that we include in the analysis. There are more BMP types than this in the database, but they may not have enough data to be included in this category level evaluation. A few comments related to fecal indicator bacteria. We do have some areas where we have some underrepresented practices pertinent to fecal indicator bacteria, and those would be some of the innovative engineered media approaches, and some of you are probably familiar with the Shingle Creek study, and we're going to hear more from Diane today with Wenck as part of the panel discussion. But that is a study that has biochar and the Minnesota sand filter design with iron filings in it. Also, subsurface flow wetlands are a good practice for reducing fecal indicator bacteria, and we don't really have any of those. Lastly, there's some excellent practices that aren't well suited to a category level analysis, but we do have data for those, and they're included in the database. And those would be kind of a development scale, low impact development, where you have really unique implementation of distributed controls, treatment trains that also are unique. As we mentioned, disinfection for dry weather flows is an effective practice. And then there's some emerging innovative manufactured devices that we might only have a few studies for as well, so those may not be included. So I'm going to be showing you some tables, and this inflow-outflow column here, I want to orient you to so that you are aware of what I'm talking about. In the BMP database analysis, we do a series of comparisons and hypothesis tests to try to answer the question, basically the question of, is the BMP doing anything? Is it resulting in an improvement in reduction in pollutant concentrations? And so you're going to see 3 symbols, and they're going to represent 3 different comparisons. The first one is an evaluation of whether the 95% confidence interval for the medians shown in the box plots, and so that's going to be this notch here, whether they overlap between the inflow and the outflow for the BMP. The second test is a Mann-Whitney test, and it looks at unpaired data, so just the population of the inflow versus the population of the outflow. And then the third box only looks at paired data, and it's the Wilcoxon test, so you would need an inflow and an outflow parameter or data point in order to run that test. And then we're going to have some different symbols. The black triangle is going to mean that there was a statistically significant reduction. An open diamond means that the BMP didn't have a statistically significant reduction. And then in some cases, we have export, and that's the red triangle. So I'm going to just walk you through the data sets that we have for 3 different types of fecal indicator bacteria in the database and kind of give you the bottom line of what we have found to date. So for the Enterococcus data set, this is our most limited data set. You can see that we've only got a handful of studies. That's the first number here, 4534, different types, numbers of studies for only a handful of BMP types. And that includes retention ponds, wetland basins, bioretention, and hydrodynamic separators. And basically what we see here is that the retention ponds, the wetland basins, the bioretention all provide statistically significant reductions of Enterococcus. Now, one of the problems we see, though, is that the effluent concentrations are pretty high. They're significantly elevated above the stream standard for Enterococcus, which is in the low 30s. And so although we're seeing benefit from stormwater BMPs, we're not seeing something that would result in an end-of-pipe attainment of a standard. For E. coli, we have stronger data sets. Again, these are not as strong as what we would see for a pollutant like TSS or total phosphorus, but we've got some pretty decent numbers of studies and some pretty decent numbers of storm events. And what we see here is basically the pond type practices provide statistically significant reductions, and then bioretention and media filters. And then if we go over here and we look at the effluent concentrations achieved, what we see is that we're again not getting down to a standard of 126 for most of these practices, even though we're seeing pretty substantial reductions for quite a few of these. Media filters and bioretention are the two that get down closest to the stream standard. However, some of the bioretention studies that we have seem to have been located in pretty clean locations, maybe say a parking lot in a commercial area that doesn't have a lot of trees. So for each of the analyses that we run, we also provide box plots of the influent and effluent concentrations for each of the BMP categories. So these are abbreviations for BMP categories across the x-axis and E. coli concentrations on a log scale on the y-axis. And the box plots are useful because it gives you a sense of, the variability of the data sets and how close you are to consistently trying to meet that standard. And so again, you see bioretention here is probably the winner for this data set. Fecal coliform was EPA's previously recommended fecal indicator bacteria for recreational water quality criteria. And again, we see the ponds provide statistically significant reduction by retention and media filters. We go over to the effluent concentrations and we see that bioretention here is the winner, I would say, given that EPA's criteria was 200. A 180 effluent concentration is a pretty strong performance. And again, we have the box plots where you can look at variability of the data sets and compare performance among BMPs. So some of you may be saying, well, what about volume reduction and load reduction? And this is absolutely a critically important part of looking at BMP performance. And we do have volume-related data in the BMP database, and volume reduction is an important component of load reduction. It can be a key tool to reduce the number of exceedance events if that's a condition for you in your permit or your TMDL. But we don't look at loads and volume reduction in these category level summaries because there's a lot of uncertainty and challenges in accurately monitoring flow. And so we've chosen to focus on concentrations. You can use our concentration data and combine it with, say, a model result or site-specific hydrologic data for your site. I'm not going to try to describe this graph right now, but basically bioretentions, even with underdrains, provide significant volume reduction and can be a key tool in reducing bacteria loading to streams. One of the things that we look at for bacteria or BMP performance for bacteria is the various removal mechanisms that are present in BMPs. So unit treatment processes and other factors, things like natural inactivation, predation, processes like filtration and sedimentation, absorption, chemical activation, and volume reduction. And so the extent to which these different processes are present in BMPs affect the effectiveness of the BMP. And then we also have additional complications when we get to behavior of fecal indicator bacteria in receiving waters. And I think Mike Sadowski will talk a little bit more about that. So in terms of our category level conclusions and observations based on the BMP database, there are a lot of words here and I'm just going to skip through these, but basically bacteria in urban runoff is really high. In bacteria in inflow and outflow from BMPs is highly variable. Kind of the winners that we have in terms of potential to reduce bacteria are the pond type practices and bioretention and media filters. Currently available data suggests that we're unlikely to consistently get down to stream standards using passive treatment practices. And some of our conclusions are limited based on the BMP types that we have that have sufficient data for analysis. And so some areas where we'd like more data are subsurface flow wetlands, more engineered, innovative media designs, and emerging proprietary devices. And a key component of one of the needs that we have is long-term monitoring with maintenance information related to the BMP. So some of you may be saying, well, what about individual BMPs that perform better than these category level summaries? So this is where we get into the second retrieval option for the BMP database, where we have a map tool where you can retrieve specific BMP studies and run statistical analysis on the fly, dynamic statistical analysis for BMP types and pollutant types of concern for you. And so one of the questions prior to this webinar is how much pathogen data do we have in the database? And the answer is not a whole lot, but I did want to use an example of some Campylobacter data from some Australian researchers for bioretention. And so basically I set my query up here, and then I'm able to retrieve statistics for this particular data set, look at how many storm events are included, and then go down and look at hypothesis testing to see if there's statistically significant differences in performance. And then the key tool is to be able to download a CSV file and look at the data sets yourself. And the bottom line here is the BMPs being looked, the bioretention studies here did provide statistically significant reductions of Campylobacter. The outputs associated with the statistical tools include some graphical representations of the data. These include box plots of influent and effluent data, quantile plots, scatter plots of inflow versus outflow, and if you're to the right of the one-to-one line here, then it means the BMP is doing something, removing pollutants. And then there's also time series plots, which give you a sense of how paired storm events performed, and also how old the data set is and how much data you have. And so to give credit here, this is again the Australians, Chandrasena, Delatek, McCarthy, and they looked at Campylobacter and E. coli for biofilters. I also want to let you know that Minnesota is actually the state that has the innovative engineered media studies that we have in the database right now, and there's only a couple of them. And I just wanted to set this up for Diane to talk later, since her firm Wenck has conducted these studies. And these included a series of different combinations of sand filters with iron and sand and biochar, and looked at performance in a couple of different locations. So one of the questions is, well, why are these data sets for fecal indicator bacteria so limited? And I have a couple of theories on that. I think that sometimes the concern may be, well, we can't meet the 8-hour hold time and standard methods, and so we don't feel like we can sample for E. coli. And I think that you'll find, I've put a couple of references here that give you some guidance that basically say, if you're looking at research and this type of monitoring, you know, if you get those samples to the lab within 24 hours, that's good enough. So I wanted to put that out there. And then I think there are also some concerns or worries that using automated sampling equipment may not give valid results. But again, I think there's some resources here for best practices by folks like Darren Harmel and John Hathaway that can give you some guidance on how to use automated samplers in this context. Real quickly, if you're looking for runoff characterization, Bob Pitt's National Stormwater Quality Database is also on the BMP Database website. So as kind of in closing, and kind of setting up our discussion for the panel discussion today, I went back to our pathogens book to look at what research needs we identified there and what unresolved issues are hanging out there on this topic. And there are a lot of unresolved issues, but I think that the points that we made in this book still remain from 2014. One is that we do need more structural BMP performance monitoring data that's field-based. Lab studies are useful, but we really need those studies to also be conducted in the field. Secondly, there's a real limitation on source control effectiveness, evaluation, and monitoring. Practices like street sweeping, for example, are an area that we could use more monitoring data. In terms of being able to conduct QMRA and risk-based assessments, we need more land use runoff monitoring for pathogens to support risk-based modeling. There is a good literature review out there by Ahmed from 2019 that does have a great compilation of pathogens in runoff that I might direct you to. And then fourth, epidemiological studies in non-sewage impacted inland flowing waters. For example, maybe a shallow urban stream with water played by children type setting. It'd be great to have some epidemiological studies for those types of areas versus, say, true swim beaches where you have high use intensity and, you know, sewage impacts. Number 5, we could use more regional reference stream studies that give us a sense of the contributions of natural sources to elevated fecal indicator bacteria in streams. And California has done a lot of work in this area with the natural source exclusion concept. I know some of the folks in California don't feel like that this tool has given them the regulatory relief maybe that they had hoped for, but I still think it's important in terms of looking at, you know, what can we realistically attain. We could use some additional molecular methods for more urban sources like raccoons. And this is something I've been talking to EPA ORD about. You know, they're great sources out, commercially available sources for birds, dogs, ruminants, you know, those types of sources, but there's some urban sources like raccoons where we don't have those commercially available methods right now. And then number 7, any kind of research supporting improved modeling related to effect and transport would also be really useful. And I think on this slide, it's actually redundant to what I mentioned on the previous slide, but I did want to mention a recent epidemiological study that was conducted in California within the last couple of years. That was a surfer health study, and it is a newer study that looks at a stormwater impacted area, or looked at increased risk to surfers during wet weather conditions. And one of the things they found is that although there is an increased risk for surfing during wet weather conditions, their study showed swimmer illnesses below EPA's allowable risk threshold. Some other questions, kind of unresolved policy questions, and I don't know that I have the answers to these, but again, these might be topics for our panel discussion a little bit later today. One is, does the TMDL process work for fecal indicator bacteria? And are there better options? And why don't we see more TMDL success stories for fecal indicator bacteria? And there are some legal constraints on what those options are, but I think it's a discussion that we need to have. Particularly since bacteria is kind of unique in that it's a moving source with legs, you know, that walks around your watershed, and that these sources we may not get to attainment of standards through a traditional TMDL process. And again, along those lines, can urban streams meet primary contact standards, and what is enough? And I think that some of the thinking that's occurring in California right now, focusing first on human waste sources, is a really good approach. And this is their process. I'm not going to talk through this in the interest of time, but again, kind of focusing first on, you know, what can we control in terms of human sanitary sources? And then in closing, the last couple of paragraphs in our pathogens book just pose some questions along the lines of the topics that I just mentioned. And I'll just read the 2 questions there in yellow. And those are, what level of control for fecal indicator bacteria is practical and attainable and reflects acceptable levels of public health protection based on actual pathogenicity and exposure under real-world recreational use scenarios? Second question is, how can measurable water quality compliance metrics for TMDLs or MS4 permits be expressed so that practical constraints are recognized while still promoting meaningful water quality improvement, and I would add protection of human health? And I think that these policy questions still remain, and so there's a lot of opportunity for a dialogue on these. And then I guess in conclusion, to recap what we talked about, or what I talked about today, is that there are some good resources that are out there to help develop a better understanding of various aspects of fecal indicator bacteria issues and to communicate with the public and regulators and environmental groups. And the themes that we see in these sources are where to start, and that's really developing a better understanding and control of the sources of bacteria during dry weather first, and then focusing on wet weather. And our stormwater BMP data shows that stormwater BMPs do in fact help to reduce fecal indicator bacteria, but this doesn't always mean that you could attain an in-stream standard at end of pipe though. So wanted to emphasize that. Thirdly, partners are important. This is a complex topic where you need microbiologists and engineers and scientists and policy folks, and solutions extend beyond simply your public works department. Improved protection of human health is possible, but consistent attainment of recreational water quality criteria may not be. And so that's what I have. I would give you the description of the photo that I have here. This is what I would call a raccoon latrine in a stormwater manhole. So I'll leave you to meditate on that picture. And I'd like to thank you for the opportunity to speak today. And my contact information is here at the end of the PowerPoint, but I think I'll leave this on the conclusions or whatever slide that John might want to leave this on.
Thank you, Jane. I'm going to give you a personal round of applause.
Okay. Thank you.
Okay, so we have some questions. They've been adding up here.
Okay.
The first is about street sweeping. Good street sweeping appears to remove significant amounts of phosphorus and solids from urban stormwater systems. Do you think, this is they're asking for your opinion, that there is potential that good street sweeping might make a significant dent in bacterial loading as well?
So I would say yes, potentially. The answer is always site specific, obviously. The area where I think that it could make a difference would be in terms of what ends up accumulating in your stormwater system. So if you're accumulating a lot of organic matter like leaves and or pet waste for that matter, then I think that can provide a habitat in your storm drain system that might be conducive to bacteria growth or regrowth there. And when we hear Mike Sadowski later talk about bacteria living in the environment, I think he might be good to weigh in on that topic as well. So I think yes, potentially, but it'd be great if we could have some street sweeping studies to support the answer to that question.
Thank you. Here's a question that I have had as well. Should the bacteria water quality standards be revised to consider the sources? Aren't bacteria from animal sources less dangerous for humans than bacteria from human sources? How should we evaluate TMDL WLAs in those circumstances?
Yes, I think that, I think a lot of us that had been following EPA's 2012 recreational water quality criteria update were really hoping that there was going to be some way for EPA to differentiate among sources of bacteria as part of the standards or criteria development process. And EPA couldn't really get there as part, as a national recommendation at that time. But there was a lot of really excellent work that was conducted by researchers around the country at that time. Some great quantitative microbial risk assessment studies. And a lot of this you can get off of EPA's website if you go to the 2012 criteria site, and you can look through some of these studies. But I think that those studies did show that risk from sources like particularly birds pose a lower human health risk. And so what that could mean if you did a QMRA for a stream where you've ruled out human sources, you could potentially provide a scientifically sound basis to have a higher stream standard that would provide equivalent protection of human health. So maybe if the standard is 126, your QMRA could, for example, support a standard of 600 and still protect human illness at the same rate. The problem is, or human health at the same level. The problem is that a lot of your local small towns or your, small municipalities are not equipped to run a study like that. And so, I think some of the opportunities may be for some of our larger cities in conjunction with state agencies to gain some experience in this area. And then maybe there would be some opportunities for specific streams that take sources into consideration. So I'd give you that for my thoughts, that topic.
Thank you. I like that idea. So if you had your choice, which BMP would you choose to reliably and cost effectively lower bacteria loadings?
Well, I'm gonna answer a different question before I answer that one. I would first say that if you have a stream that's exceeding stream standards, your first step really is to figure out, do you have a controllable source related to your infrastructure that you can fix? So have you first done dry weather sampling of your outfalls, and ideally used human markers like the HF183 molecular marker to identify whether you have sanitary sources, like it could be an illegal connection to your storm system. It could be a leaking sanitary sewer that's being intercepted by your storm system. So I'd say first focus on your source controls and good pet waste practices. And then as you're implementing stormwater BMPs to reduce all pollutants in your watershed, sediment, nutrients, metals, and bacteria is of high priority to you, then practices like bioretention and media filters that provide filtration and sedimentation, sorption opportunities, those are going to be the most likely to get your concentrations down in that lower level close to your stream standards. But I would also say some of the pond practices like wetland ponds and retention ponds also have a lot of unit treatment processes present that can also reduce bacteria concentrations. If volume reduction is a target, then you're probably going to want to go, or is a priority, then bioretention is going to probably be your better choice there.
Thank you. So here's another question. We promote infiltration where feasible as effectively reducing bacteria loading to surface waters. Many people are concerned about impacts to groundwater. What sort of thoughts do you have on this?
That was one of the questions prior to the webinar, and I have been thinking about this. I'm not sure that I have an answer on that. Again, that might be a good one for the panel to discuss. My inclination is that, well, I'm going to go back to your source of bacteria, my source of bacteria comment earlier. If your sources of bacteria are kind of diffuse type animal sources and you're infiltrating, my gut answer, not based on a scientific study, would be that I would think the risk would be relatively low. Now, if you've got a drinking water well in the area that you're infiltrating, I think that might be the answer might be different. If your area that you're infiltrating has, say, high levels of homeless encampments where you have people that don't have access to sanitary facilities, and you have, significant human sources, then I would say the risk would be higher. I think it also depends on your soil conditions. Are you in a sandy area? Are you in an area, clay area? What kind of transport are you having subsurface? So the answer is really kind of site specific. I would say, there are studies in, beach areas where you have bathrooms that have leaked and you have bacteria transport through the sandy beach area to the ocean or to a lake. And so the answer is, transport and contamination is possible. But I don't know that it's a black and white answer. And I would also go back to Bob Pitt and Shirley Clark do some work for EPA a number of years ago related to this topic, and it's a I don't have the title in front of me, but it's something that you could download for more information on that.
Thank you. We'll also talk about that probably during the panel discussion because Anita Anderson
Yeah.
from the Minnesota Department of Health is on the panel.
Yes, that'd be a good one for the panel.
Yeah. Okay. Here's one. This is a tough one. Are there any examples of MS4 permitted cities that have successfully achieved a TMDL WLA with a significant pollutant reduction for bacteria? Has it ever been done?
Well, that's a great question. And when I started preparing for this talk, I actually had an intern go and try to download TMDL success stories to try to find the answer to that question. And my understanding right now is that there have been TMDLs where reductions have been achieved, but I have not seen success stories where the receiving water consistently achieves the stream standard. There may be some exceptions to that general comment in areas where you have, say, a single beach that has a very limited drainage area where you have a lot of control. I think I may have seen one success story there, but I think in general, it's difficult to meet those waste load allocations. And also I would add to that is, TMDL waste load allocations look different depending on what state you're in. And so it also kind of depends on how your waste load allocation is formulated and, what your compliance metric, how it's assessed. But I would say few if any.
Okay, right. But there are a couple.
I think that I've seen one.
Okay, all right.
So, but it's well, actually, I'd like to say, one of the things that is hard right now is when you go to try to research this topic, there's really not a centralized source of information where you could look and see, okay, this TMDL has been achieved and it was achieved for these reasons. And here's the monitoring data that shows it was consistently achieved. You tend to get more anecdotal information, or you might have streams that are no longer listed as impaired, but you may not know why they're not listed as impaired. Did the stream standard change? So it's not a quick answer.
Okay, here's one that is highly liked. I think you answered it, but they're probably looking for further assessment. To what extent do existing stormwater BMPs contribute to bacteria loading? So which one is the worst offender, in your opinion?
I would say, well, I would say practices where you have a material that accumulates and that can be a breeding ground for bacteria would be, or BMPs that aren't maintained, where you have a lot of accumulation of organic matter and sediment. BMPs that have those conditions would be of concern. I think there are some categories of manufactured devices that have shown export of bacteria. Not all of them, but some of them. Ponds, I don't think wet ponds don't tend to be a problem. I think I saw wet ponds listed there. And these are based on the data that we have in the database, is what I'm using to formulate my comments. But maintenance is important for any BMP type.
Okay, thank you. So on the topic of BMP monitoring, we're continuing to use E. coli to assess the effectiveness of reduction practices. Given the limitations of E. coli, what should we be monitoring for?
Well, this gets into the issue of, why are fecal indicator bacteria used in the first place instead of monitoring for pathogens? And the answer is that fecal indicator bacteria are much easier to monitor for, and they're much less expensive And so they're within reach of communities, you know, to use this for monitoring. If we get into monitoring individual pathogens, then it's just a lot more complicated, and you know, you're not monitoring for one pathogen, you're monitoring for multiple pathogens. So you know, I think that there is some research out there going on related to looking at some coliphage options. And again, this might be something that Mike and Anita might be better suited to answer. But as of right now, fecal indicator bacteria, I think, are what most municipalities are using. Now, if you get into if you have resources to get into quantitative microbial risk assessment, then there might be some other options. Let's keep that one for panel too.
All right, okay, thank you. So here's the last, I'll have one more question. And this is kind of dear to our heart, but someone else asked it. What types of amendments in bioretention filter media have shown promise in reducing bacterial levels?
Well, I think that the biochar amendments have shown promise, and I think that it'll be great to hear from Diane on that topic. I think one of the questions that we have on some of the innovative, you know, media amendments that are being studied out there is how they perform over time and how they perform in the field with, you know, real stormwater, with natural organic matter and so forth, versus the ideas that we come up with in laboratories, like how do those translate as we move out into the field. But I do think biochar is one that's showing promise right now.
Okay, thank you. I'm going to give you another round of applause.
Okay, thank you.
Welcome back. We are going to continue our Minnesota Stormwater Seminar Series with the panel discussion, talking around bacteria and pathogens in urban stormwater systems. To start, I would like to introduce our local experts and ask them to give their relation to the topic that we have today. Our first panelist is Anita Anderson, who is a principal engineer at the Minnesota Department of Health. Anita, from your perspective and experience, how do you relate to this topic?
Well, thanks for this opportunity again, Andy. So I work for the section of drinking water protection, and part of our work there is to protect sources of drinking water. So we would be concerned if stormwater that ultimately reaches rivers and lakes that are used as sources of drinking water contain pathogens. And we also recently conducted a study of pathogens in drinking water wells, and we wondered, that question that was asked earlier, if infiltrating stormwater could be one source of pathogens in groundwater, and or just if stormwater was helping transport pathogens. And secondly, there's a growing interest in Minnesota to harvest and use stormwater, mostly for non-potable purposes like irrigation and toilet flushing. And as the public health agency, we need to evaluate if these practices are safe and protective of human health. And it seems that pathogens are likely the primary concern in these applications. So that's our interest.
That's great. Thanks, Anita. Our next panelist is Mike Sadowski, who is a professor in the Department of Soil, Water, and Climate at the University of Minnesota and the director of the Biotechnology Institute. Mike, from your perspective and experience, how do you relate to this topic?
Oh, thank you very much, Andy. I appreciate participating. So over the last approximately 25 years, I've been very much interested in looking in E. coli, not only as a fecal indicator bacterium, but for its ability to survive in the extra-intestinal environment. And for those of you who've had microbiology classes, you probably heard some teacher tell you that E. coli lives in the intestinal tract of warm-blooded animals, and I was told the same, but as we explore this area even more, we find out that E. coli is fairly adaptable and can live out in the environment, both in sand, water, on beaches, in detritus, and not only does it survive, but it multiplies in some of these environments. So as one of our people asked a question, does that then preclude the use of E. coli as a fecal indicator bacterium? And those are the particular areas I've been interested in exploring, along with new molecular techniques to determine sources of bacteria in the environment, not only in relation to water quality in terms of fecal bacteria, but also in general to bacteria in the environment. And looking at rivers, streams, creeks, and lakes, and how does the microbial population support recreational activity, as well as maintaining public health.
That's great. Thanks, Mike. Our next panelist is Diane Spector, who is a Senior Water Resources Planner and Principal at Wenck Associates, and she is representing the Shingle Creek and West Mississippi Watershed Management Commissions. So Diane, from your perspective and experience, how do you relate to this topic?
Well, thanks, Andy. I've got a kind of a dual perspective. One is somebody who undertakes TMDLs and attempts to identify and quantify sources of E. coli and other bacteria to receiving waters, usually rather unsuccessfully. You can do your best to tally up all those sources, but they never match the actual loads that you're seeing in the receiving water. So it's both better understanding how those pathogens and bacteria are actually generated and transported to the receiving water, but also then as a practitioner that has to figure out how to address those pathogens and bacteria once they're actually in the receiving water. How do we do that? How do we reduce the load coming in? And then once it's there, what do we do about it? So we've been partnering up with a number of different academics over the past 4 or 5 years to test various types of approaches, BMP approaches to reducing bacteria, specifically in Shingle Creek.
That's great, Diane. Thank you very much for that. And it's great that you can bring that perspective from multiple sides. So we heard Jane's relation to this topic. I think that was a great talk. It really set the stage for this panel discussion. So what I'd like to do is I'd like to dive right in, and we probably will come back to some of the questions that were asked at the end of Jane's presentation, just so we can get some local perspective on those as well. But what I'd like to start with is this concept of the prevalence of E. coli, fecal indicator bacteria, pathogens, just in the natural environment. And I'm going to start with this question. So when we're talking about TMDLs and trying to make compliance, right, and whether that's for permitted cities or other entities that might fall under a TMDL, we find these bacteria in high concentrations almost everywhere, right? And we see that they can grow and multiply, as Mike was saying in his relation. So how do we deal with compliance? How can we meet standards when we're not sure if the sources or the contributions are something that we can actually control? How do we separate the natural background from things that we are actually impacting, and whether that's human impact or animal impact, like we saw in some of Jane's slides as well? So I'd like people to chime in on that. So go ahead and raise hands if you'd like to start. Go ahead, Mike, please.
Yeah, I could take a stab at that. So I think in Jane's discussion, she did mention that in cases where the issues can be corrected, in other words, a BMP can be created to reduce numbers, one should do so. Really, to say that, oh, these are probably naturally E. coli growing in the environment might be a cop-out if you don't actually look carefully at what the potential input sources are. So first, you need to look for potential input sources and see if a BMP can reduce those loading. And then if you, in the absence of that, and you could show that there actually is growth or regrowth, then that data should be brought to whatever administrators you're working with to ask that something could be done about the TMDL listings that might have happened.
Would anybody else like to chime in on that? Go ahead, Jane, please. And then Anita, you can go next.
So, you know, one of the things that I agree with Mike's response, by the way, and one of the things that I think I would add is the bias that I came into this with in the watershed, in a couple of watersheds that I work in Colorado, is that actually all these communities have done a great job with preserving wide riparian corridors along streams where there's lots of bird activity. lots of wildlife. And my bias going in was that I thought that it was all natural sources. I mean, but for all of the streams that I've worked on that have done dry weather investigations of stormwater outfalls, using molecular methods like the HF183 marker for human DNA, there have been human sources that need to be corrected. And so I really do agree that you do need to go through the process to find those correctable sources. And then you may still not be able to meet the standard, but you'd need to go through the process.
Go ahead, Diane, please.
Yeah, I agree with the speakers, but also wanted to add that one of the things that in the Shingle Creek study, that the work that we have been doing has been not only addressing the bacteria contributions at the source, but also in the drainage system itself. There are some options in there for downstream types of BMPs as well.
Did you want to elaborate on that? Do you want to talk about those more? You can if you'd like.
For those who aren't aware, the Shingle Creek biochar project looked at adding biochar to iron enhanced sand in several different filter applications at different places along the drainage system. So, for example, fairly high up in this system at the catch basin, we designed a filter that actually was inserted into catch basins to treat the runoff as it was immediately entering the drainage system, with kind of mixed success, but we did actually achieve some reductions in the E. coli concentrations in that runoff just through filtering the runoff through these very small filters in the catch basin inserts. We also looked at adding biochar to the Minnesota filter, the iron enhanced sand filter. So kind of in part of the collection system, so that as that water is transported to a detention pond through the storm sewer system, it gets then filtered through that filter before being discharged either further down into the collection system, or in one of our cases, it was actually just that pond discharged directly into Shingle Creek. Then we also, as kind of a test case, it was fairly limited, but we actually did a stream bypass where we were able to treat flow taken from the stream, treat it, and then return it back to the stream at a much reduced concentration of E. coli. So there's a lot of potential with biochar, and as a kind of an intermediary treatment media.
Great, that's a great example and case study for how these kind of practices could be applied and really tackle this issue. And I do want to, if anybody else has any comments, we can chime those in. But what I'd like to do is kind of go the opposite of that then, and go back to a question that we had. To what extent do existing BMPs contribute then to the loading? How do some of our treatment practices that we're trying to achieve other goals, volume reduction or rate control or removal of other pollutants like sediment and phosphorus and things like that, how do those types of BMPs actually contribute to this bacteria pathogen or even fecal indicator bacteria problem? Does anybody else, maybe from local studies, that might have some information on that to add? Go ahead, Diane.
Yeah, just based on our monitoring data, again, in the Shingle Creek watershed, we've taken grab samples out of sumps, some of them fairly large sumps that are intended to provide regional treatment, and found very, very high concentrations, much higher than what was in the inflow itself. So there's obviously some reproduction happening within that structure.
Go ahead, Mike, please.
I do know of some examples, not necessarily here in Minnesota, but in Wisconsin, where a storm runoff catchment was located too close to a beach area, so that the BMPs that were initially developed to remove stormwater ended up contaminating, in this case, a different medium. It was beach sand. So I think the ultimate fate of the BMP needs to be examined.
Go ahead, Anita, please.
I can't say I have data to support this, but I guess just from what I know about maintaining other, water and wastewater distribution systems, it might just be, a lot of these things are passive and you don't think about them much when stormwater isn't flowing. But I think if we can focus on kind of maintaining things kind of consistently so that they're not just sitting there, maybe a flushing routine could be a good idea.
Well, so then what I'd like to do is pivot to some of the questions that were submitted prior to the seminar. So for those of you that signed up early, I sent an email to all the registrants asking you to submit questions so we can get to all the questions. And I want to address some of those questions right now. And the one I want to tackle first is this concept of the linkage or maybe the disconnect between using fecal indicator bacteria and actually the pathogens or bacteria that are harmful, right? So how well do our performance assessments or the way we're measuring our metrics and our performance, specifically on indicator bacteria, actually address or connect to pathogen removals or reductions in our receiving waters? Is there a connection there, or is there a strong disconnect? Should we be, and this gets back to another question, should we reevaluate what is our endpoint, what is our goal, and what are our metrics? So I'd like to hear your comments and thoughts on that. Go ahead, Anita, please.
Well, maybe I'll start. And again, all my stuff is kind of going to have a little bit of a drinking water bent, so I apologize for that. But, I think, again, on the drinking water side as well, the indicator bacteria are still our primary tool. We've been wanting something better for a long time. And, it's exciting to see the molecular methods coming out now and getting a little more accessible, but they still aren't the everyday thing. Although I probably have more hope for the development of new molecular methods that will really give us that pathogen information that we want versus trying to actually correlate indicator bacteria to pathogens. But, I think, again, on kind of a gross level, again, drinking water, we know that our fecal indicator bacteria monitoring has gotten us a long ways to improving quality. So that's the first step. And stormwater may be a little bit behind there, but still, I'm sure you've made lots of improvement in managing stormwater based on the indicator bacteria. Now we're trying to get even better, and part of it's going to just have to be working with what we know and making those gradual improvements, and keep working on improved methods.
Yeah, that's great. Mike, did you want to chime in on that too?
Yeah, I think the new methods that are being developed are, some of them are being proved to be very useful, but some of them really don't get us further in the question that someone raised relative to the public health implications. And I think, a lot of the stuff that's been put out there now is based on some epidemiological studies that were done initially in ocean water beaches and then later on the Great Lakes beaches. However, there's still not a great linkage between fecal indicator bacteria, E. coli, and public health outcomes. And as Jane mentioned, I think if you want to do quantitative microbial risk assessments, I think those need to be done along with some other tools that actually get at the pathogens of interest. And I know that it's more expensive to determine some of the pathogens, but I think it's really needed to maintain public health.
Right, and I think, we kind of alluded to it, but one of the biggest challenges is we're using fecal indicator bacteria then as a surrogate to represent a large number of different pathogens and bacteria that all have different interactions, right? So I think that's a big challenge, and we can't, we could probably spend a whole hour, right, Mike, just talking about all the different things that we need to worry about in this kind of broad category.
Exactly, and with the EPA's new requirements, at least for saline environments, to use Enterococcus, and the migration of the Enterococcus standard to inland waters, the problem is even getting greater, because if I was going to look for a bacterium that survives in the environment, I would choose Enterococcus because it can survive almost everywhere.
That's great. Other comments or other?
I guess just one last thing. Even on the different, even if we can monitor pathogens, I guess, of course, we're living in this COVID world right now where we see right now, COVID is the primary thing circulating in our community. Next year, it might be something else, or the flu virus changes every year. And so, monitoring for pathogens is tricky because at first often has to be circulated in the community to look for it. So if you try to kind of set one standard thing you're trying to look for, there's just so much changing all the time in this community.
Yeah, it seems, go ahead, Jane, please.
Oh, well, I was going to maybe answer the sort of the end part of your question about, well, what alternative metrics would we want to brainstorm about for in a regulatory context for MS4 permittees, for example, because I do think MS4 permittees are the ones that really end up on the hook from a regulatory perspective. And often MS4 permits have, compliance schedules, that assume that you're going to meet this, that you're going to be meeting the standard, within 5 years or maybe 10 years. And so I guess in, an unconstrained regulatory situation, what I would choose would be to say that MS4s should do diligent investigations to identify human sources. I think programs related to illicit discharge detection and elimination are already in MS4 permits, but they're fundamental on the E. coli topic. I do think that the commercial availability of using the HF183 marker can be useful to identifying whether they're human sources. And looking at your trails and parks, do you have pet waste cans and bags that at reasonable increments that, where people are willing to carry the bag to the next trash can? Looking at things like that, looking at, do we have situations where we have homeless encampments along the river that, where services are needed for those communities? Where are the controllable sources? And if an MS4 has jumped through those hoops and completed those actions, then I think that is one endpoint that could be a metric. The next, in parallel to that, we need to be implementing stormwater control measures on new developments and redevelopments for many pollutants. And so those practices need to be diligently implemented in parallel. We need to have good maintenance practices and schedules in place for our BMPs. And so those things, I think, are metrics and benchmarks that can be checked, But then if an MS4, and this is in my head, but then, if you have a receiving water that has, environmental sources, natural sources of bacteria living there that you can't control, then maybe the MS4 has done what they can do. And, continuing to throw money at something or putting UV disinfection on every outfall for, dry weather sources, maybe that's not how we want our communities spending money. And I know that, for example, in Denver, with some of their permit requirements as a city, they were committed to meeting their MS4 commitments. And so they did put UV disinfection on some outfalls. And Andy, you're muted, by the way. But so anyway, so those are kind of some of my thoughts on kind of the regulatory endpoint. And how much is enough, I guess, is how far to go on some of this.
Yeah, go ahead, Diane, please.
Yeah, I'm thinking that this especially in the urban areas, this really parallels the chloride situation, where again, it's something where you're simply not going to be able to eliminate it from the environment, but there are a suite of BMPs that all of the MS4s could be undertaking, and once you check those off and you're diligently practicing those, again, as Jane said, that may be really all that you can really effectively do.
Go ahead, Mike, please.
Yeah, and this might sound strange coming from a molecular microbial ecologist, but there's a lot of techniques that one can use that don't involve fancy molecular tools or fancy other detection technology, but rather a set of good eyes. Because in a lot of cases, people tend to think that it's some really bizarre input source around, or blame it on something else when there hasn't been a careful site study. And I've found cases where there's leaking septic systems only because I sunk in there almost up to my ankles from a leaking septic system to figure out that it wasn't something complicated. So I think using your eyes and thorough understanding of the area of interest is the way to start out. And then use molecular tools to finish off your analysis.
Right. So that gets to, you know, our source tracking, our source assessment, right? It's more than just collecting samples. It's visual observations. It's understanding the watershed and understanding, you know, the entire system and thinking about, well, where could this be coming from? What are the possible things? And then kind of narrowing in that, right? What about, so then thinking about homeowners and property owners, right? Is there a way that we can engage the community and give them some simple things? Because they're not going to do these advanced techniques. They're not going to necessarily collect samples for us, although they can. We can have citizen scientists. But is there some ways that we can engage the public and the community and the homeowners, the property owners, to be, just to make them more aware of some of these things and how they may help in not only reducing sources, but then identifying sources or potential contributors in their areas? I don't know if any of you have any examples or some suggestions or recommendations on that for communicating with the public, the homeowners, the property owners, and engaging them into some of these activities to help. Go ahead, Diane, please.
Well, I can give you an example from my own neighborhood in Minneapolis, which, you know, probably one of the things that's hardest for neighbors to talk to each other about is if your neighbor's not doing a good job cleaning up after their pet. The neighborhood association actually designed and made available door hangers that you could in the middle of the night go and hang that on your neighbor's door. That gave lots of information about, you know, why do you clean up after your pets? Why is that important? You know, what are the risks associated with it? And please be a good neighbor. Thank you very much.
Yeah, that's a great example. Anita, did you have something too you were going to share?
Yeah, I was just thinking, we run the Lake Superior Beach program out of this office, and they always do what seems like a fun activity to have the kids, you know, say, where's the poop coming from in the lake? And I think if you did something like Mike was saying, where you're just looking around your yard, where are all those potential sources? You know, it is, whether it's a good game or it's just a good practice to look around and see where things might be coming from. But that seems like an effective thing for the beach program.
Jane, did you have something too?
Yeah, I would agree with all of those comments. And then I would also add that trash management in Colorado, you know, raccoons, bears, you know, there are a lot of reasons to have secure trash receptacles with lids that are keeping, you know, rainwater from going into your trash and leaking out down the gutter as it's sitting there waiting for the garbage truck to pick it up. And also just in terms of trying to manage some, to the extent that you can, maybe urban wildlife, if you reduce some of those food sources, then in theory, you know, maybe they would go elsewhere. And then I think another practice would be landscape management practices related to irrigation overspray and looking at that transport mechanism of, you know, the flows that you know, if you can control the flows coming out of your storm drain during dry weather, that's something that a homeowner can do is, you know, control their irrigation. For businesses, you know, food dumpsters and, you know, wash down practices and things like that. A number of years ago in Colorado Springs, pigeons were implicated as a source of elevated bacteria in a stream there, and there was, you know, power spray wash down of, you know, pigeon droppings that was part of that source. And so just kind of thinking about how you're cleaning up surfaces that have fecal waste on them, I think is another area.
Diane, were you going to add something too?
Yeah, some years ago I worked on a project in the city of Rochester, Minnesota. And some of you may be, if you're familiar with Rochester, you may be familiar with Silver Lake, which is just outside of downtown. And the City of Rochester Municipal Power Plant is located right on Silver Lake. It discharges their discharge water into the lake and pretty much keeps it open most of the winter time. So it's a big goose gathering spot. And it's on a flyover spot as well. So they at one point had the DNR go out and do an animal count, and they counted upwards of 40,000 geese on this one lake, stopping over during the migration season. So the project that we worked on was to install a wide vegetated buffer along the lake itself, which took quite a bit of conversation with the community, because it was kind of a well-known family practice to go down to the lake and feed the geese. In fact, there was actually a nonprofit that actually operated corn feeding stations along the lake. So once the city had those removed, and it was a big community conversation about the need to reduce the goose population on this lake, because it was such a big contributor to the bacteria impairment on the lake and on the Zumbro River. So, those were some hard conversations for people to that like that ability to interact with nature. Canada geese aren't the friendliest bit of nature to interact with, but it did take it was not an easy discussion and conversation with the community to have with the residents.
Yeah, that's a great example where it's not only engaging the community, but it's a challenge because they're going to be resistant, right? That's something that they're enjoying, but trying to convey the balance of how do we prioritize our water quality, right, and our water resources over some of these recreational things. That's a great example. I think Como Lake had a similar thing where they wanted to put vegetated buffers around certain portions of the lake, and that was a challenge because walking paths would go by the lake. And there'd be a lot more tall grass, and I think some of the residents were a little resistant to that vegetative buffer around Como Lake too, or at least portions of it. So that's great. Those are great examples. I'd like to go to another question that came in from the Q&A from our live audience, and the question here is about research questions. So Jane mentioned that there are still unanswered questions even from the 2014 report, right? And so the question is that because there's little research being done in this area? Or is it that the research questions are so big, or the topics are so difficult, or there's maybe so much uncertainty, right, that we can't get good answers for these questions? And I think this is a good question also for our local panelists, thinking about the questions that we have as a stormwater industry in Minnesota and how we're tackling this with TMDLs and regulations and policy. So think about these unanswered questions and why those are still unanswered and how we can make progress to getting answers for them. So who would like to go first for that? Go ahead, Anita, please.
Take a crack at that. And again, I guess I've been involved with the stormwater, mostly from the reuse side of things, maybe 5 years or now, and yeah, I think part of the problem, especially dealing with microbes, is just really the variability. There's so many different conditions you're looking at, so many different types of microbes and situations. So a couple research projects we've been working on. My colleague Jane DeLambert has been studying an urban stormwater reuse site, looking to see if there's this site does both reuse and infiltration. So we wanted to know if there was pathogens in there that might either be a problem in the reuse situation or in the infiltration situation. And we did find some pathogens in the cistern. We didn't see them, and we did see them also in the shallow groundwater, but not in the deeper monitoring well. But if we think about that, that's 1 or 2 year study, but that's just one site we talked about all the different geologies there are. So can we really make major conclusions off of one site? No, it's a great step in the right direction, but we still have a lot more study to do. We've talked a bit here about the quantitative microbial risk assessment, and we've been trying to do that again on the stormwater reuse. But even we've got 2 years of samples from different systems, but we only have a couple samples from each system, and we just see these wild variations in pathogen content. And so if you have a dry year or a wet year and trying to monitor all those things, I think there is a lot of work being done, but it's just going to take a lot of time. And again, if I go back to drinking water, our proven methods have been studied for at least a half century, and you know, some of these things are still pretty new on the scene. So that's my thought.
Other responses? Go ahead, Jane, please. And then Mike, you can go next.
Yeah, I would say there's a lot of research being done. I would say some hot spots for some of this research would be Stanford. Dr. Ali Boehm is doing a lot of research looking at different media options. For example, Monash University in Australia is a really good source of information. And so I do think that, and then actually throughout California, where they have some really substantial economic drivers, because some of the original watershed implementation plans had price tags like $3 billion with a B, you know, really heavy economic drivers. So they've got incentive to do research and work there, and there's a lot going on. SQUIRT, Southern California Coastal Water Resources Program, they've got a lot going on. But it does take time to do these studies, like years in some cases. And then sometimes I think in some of the areas where they thought that they might have a receiving water where they could say, do a QMRA to justify an alternative standard, then maybe they find a human source that needs to be corrected, and then you kind of got to start over, or, you know, the situation's not what you thought it was. And so that's, I mean, I would say that. And then I would also say on the stormwater BMP monitoring side, you know, monitoring is expensive and it's messy, and, you know, talking dry weather, wet years, you know, out here, maybe you monitor and it's a dry summer and you only get 3 storms, and that's not really enough to interpret performance. So I think it's just a time related issue, not a lack of work on the issues issue.
Yeah, Mike, did you want to chime in on that too, please?
Yeah, I just want to second what Anita said. And part of the issues are that the environments vary greatly, and that getting results from one study doesn't instantly translate into another area with the different climatic conditions. And so in a ways, you know, more research is needed to figure out what unifies many of these things that we're finding. And that's going to be a great challenge, but I think it's going to prove to be really interesting.
And, you know, with any of these living systems, you know, when we're talking about sediment, where it's kind of a fixed pollutant, right? You can remove it with certain practices in certain areas, and that's that. But I feel like with a living system like bacteria and pathogens, you can make one change, you can identify one source, eliminate that source, and then the other sources might change, right? They might grow and might have not only bigger impacts, but even relative to what they were prior to, right? Mm-hmm. So that can be a challenge. So this, I guess, did anybody else want to comment on that or add to that piece?
I do want to add one additional point, is that several of the techniques that are used to detect pathogens actually detect what I call potential pathogens. And we actually don't know if they're pathogens or not, because we just look at them as a microbial taxa. So we say, like, for example, I use E. coli, which confuses everybody. 99.999% of E. coli is relatively harmless to humans, but it's the few pathogenic E. coli that gets all the news, and then people confound E. coli with pathogenic E. coli. And the same is true for some other of these microorganisms that are detected by molecular means. It doesn't mean that they actually are pathogenic, it's just potentially pathogenic. And people just need to recognize that.
And you know, that gets back to the engagement, community engagement and education and outreach, right? That can be a big challenge, is you require a lot of knowledge to be able to really understand this, even the problem, right? The premise and what's really an issue and what things are not really an issue. But again, with media and the popularity that some of these outbreaks get, that can be really challenging to overcome. Were you going to add something, Jane? Okay. So what that actually leads into another question that I'd like to take, related to our limited resources, right? So if we need to do more research, we need to do more data collection, more monitoring, and again, that's expensive and challenging in its own way. But the question is, if we have these limited resources, but we still want to move the dial forward. How should not only the funding agencies, but some of the other entities that are trying to make progress on this work, or people that are representing TMDLs or constituents within TMDLs, how should we focus our limited resources? What's the low-hanging fruit? What's attainable? What are things that we can do to move that needle forward that isn't a big, $5 million study? Do you have any recommendations or any ideas for how we can do that on local levels or larger levels, but kind of make some positive progress? Go ahead, Jane.
Yeah, and I would just use some examples, or the example of the Watershed group that I work with. And, it's not we're not doing $100,000 studies, but what we are doing is we have a 33-mile stream reach, and we've kind of divided that in half. We've gone out, or I would say I went out on my bicycle and stopped and looked at every stormwater outfall along the way, documented whether it was flowing or not during a dry period. So in April, October time periods here are pretty dry, and documented, is it flowing? As Mike noted, simple observation: does it smell? Does it have toilet paper in it? Does it look polluted? And then for those outfalls that are flowing, we collected, low-cost E. coli samples that our local wastewater lab could analyze. And then for those outfalls that had elevated E. coli, we did some targeted HF183 analysis, so that we're not sampling 150 storm drains. We sampled more like 12, and did that 3 times. And I think that gave us a good starting point on outfalls that we could kind of rule out as, these are probably not problems, and then ones that we were able to ask the local municipality to see what do they have on their CCT investigations for those storm drain networks. And what you can work up through a storm drain network and look at different nodes, or do you have flow contributions or not, and kind of narrow those down and use techniques that local governments may have in-house, and then prioritize improvements as part of your city's capital improvement program that way. That would be something that I think was within reach for many local governments.
Yeah, that's a great suggestion. Other comments or other ideas for how we can move the needle forward? Go ahead, Diane, please.
Just as we've been kind of talking about all along, which is, observation, just very systematically, understanding what's going on in your watershed. There are some simple things that you can look for. You can do some targeting outfall analysis. You can look for animal concentrations. Are there gatherings of like the waterfowl on Shingle Creek over my shoulder here that are contributing their own little bit of bacteria to the stream? But do you have concentrations? You have golf courses where Canadian geese are gathering. You have dog parks where there's a concentrated outflow going directly into a storm sewer. Your I&I program. There are things that you're already doing, making sure you've got an education and outreach program. There are goose control programs. There are a lot of low-cost programs to just make sure, just cross them off your list and make sure that you're doing all of them before you even have to spend $1 on a capital project. But I would also like to chime in a little bit more on the biochar, which is that biochar is really inexpensive. Is on the biochar projects that Shingle Creek did, on the pond filter, which was each one cost about $75,000 to $80,000 to retrofit. Only about $1,000 of that was the biochar. So it's a pretty inexpensive way of, if you've got those concentrated inflows coming in, of being able to do an iron biochar enhanced sand filter in a catch basin, is a really simple and cost-effective way of starting to address some of those flows.
That's great. Other comments?
Yeah, I think the other part we're missing is public education. So I think the public really needs to understand this. And they also need to know that water, regardless of where it is or where it comes from or where it ends up, is naturally colonized by a large number of bacteria. And that these bacteria we're talking about is a really small percentage of what's out there. So people just hear, they sort of freak out. Microorganisms, bacteria, water, oh, I'm gonna get sick. But I think public education, putting it in some proper context will be really helpful.
Yeah,
I did a survey, for example, and I'm not finished analyzing it, of well water in a whole county. So it's fairly extensive. But I'm really leery of presenting the results back to the homeowners because they're going to see all these microorganisms and just freak out. So we're trying to frame it in the proper way to show them which are natural, which are involved in nutrient cycling, which ones are involved in biodegradation, so they don't just see microorganisms and lose sight of the forest through the trees.
Yeah, Jane, go ahead, please.
Yeah, well, I wondered if I could ask a question to Mike, if that's okay.
That's fine.
Yeah.
So I would be really interested in hearing a little bit more about your research related to bacteria regrowth in the natural environment, biofilms, sands, some of the work that you've been doing recently in that arena.
I'm happy to talk about it. I have to say that the origin of these kind of questions actually came from Professor Fujioka in Hawaii, who was looking for negative control on the campus property, and no matter where he looked, he found E. coli in the soil. So that prompted myself and some of his students, Murali Bayapanahali at USGS, to continue with these questions. And it has morphed from questions of soil to questions of water, questions to biofilm, questions to beach sand, and all those environments are conducive to microbial regrowth, assuming that the nutrient load is sufficient to allow them to grow. And even if they don't, they will survive. And even in northern Minnesota, up near Lake Superior, we dug out some frozen soils and looked at those, and there's E. coli in frozen soils, and then we can follow their regrowth in the spring season. So I think the question that people have to look at is, what came here first? And the bacteria actually here first before humans. So whether there's natural E. coli different from intestinal E. coli, that's an active area of investigation. But suffice it to say that the E. coli are fairly adapted to the environment and can regrow. And if there's water, nutrients, and something to attach to, they're going to do that. So that's why you find them everywhere. But it's important to separate the questions of regrowth from new input sources. And you can do that with some molecular tools where you can actually tag an individual bacterium and follow its population growth over time. So before one can claim, oh, this is probably due to regrowth, you actually really need to show it. That answer your question?
So,
and I think some work of Sandra McClellan at University of Wisconsin-Milwaukee has shown that the stormwater environment biofilms are really conducive to regrowth. And she has developed actually a molecular probe that can detect those microorganisms originating from stormwater biofilms.
That's great. And I'll just mention for everybody that's in here today, the questions, we're not going to be able to answer all the questions today, so we will be copying those and sharing those with the panelists and with Jane, our speaker, giving them an opportunity to try to provide some additional answers and resources. We'll provide links to some of the things we've mentioned today, but there's just a couple more questions I'd like to tackle before we close. And the first is, we've been talking about a lot of individual practices and treatment practices, but a question that comes up fairly often is about reuse and rainwater harvesting systems, and specifically related to bacteria and pathogens, because those type of systems can actually redistribute these things across our landscapes, whether they're being used for watering and irrigation, or reuse systems are being used for plumbing, indoor plumbing and things like that. So what can we do, or what do we know about the relationship between bacteria, pathogens, fecal endocardial bacteria, and our reuse and our rainwater harvesting systems? Are we at a place where we have a set of best practices, or is there still a need for improvements, more innovations, and maybe more investigation in that relationship? Who would like to go ahead, Anita? Go ahead, tackle that.
Yeah, well, so that's, I think I mentioned one of the things we've been trying to research and evaluate at the health department, and we've been partnering with Tim LaPera and Satoshi Ishii at the University of Minnesota. And I guess where we are now, I think I kind of mentioned we've been studying it for a couple years. We have some initial data, and of course we are also reviewing all that data from the researchers that Jane mentioned, and trying, I think what we heard when we started looking at this was, is Minnesota conditions the same as California or the same as Australia, where a lot of the research had been done. So we really wanted to start and get some Minnesota data, see how it compared. And again, I guess we're still at a point where we don't have as much data as we would like, but we definitely do see some pathogen content in rainwater and stormwater, and in these reuse systems. It's not, crisis mode scary or anything, but there's a potential there for people to get sick. Again, thinking again in the context we're in with COVID, for all these questions we're still asking, what's the dose people need to get of these organisms to be sick? And are they going to be in contact with the spray from irrigation? If it's being sprayed on an irrigation field, do we have to worry about hand-to-mouth contact? So if you're touching the turf, and we've all heard we're not allowed to touch our face anymore, it's the same thing that we've been kind of looking at with these reuse systems. And I think, kind of where we are now is, we know enough that we think we should be taking some general precautions. A lot of the things we've talked about, just kind of looking for those obvious things. If you're collecting rainwater for reuse or stormwater, are there these obvious sources that might be contributing pathogens? Are we just taking basic care and maintenance of the systems? Are we doing some base level of monitoring, not necessarily ongoing monitoring for pathogens or anything, but just, is my system working? Those sorts of things. Are we committed to having someone operate the system properly? And where there is a greater exposure or a sensitive population that might be exposed, then that's when we might have to go to the treatment like UV or filtration or something that's more concrete treatment on that.
Sounds like we have some good steps so far. Mike, please.
Yeah, and I know this might sound contradictory what I said previously, but I think we can learn a lot from what others have done. And as far as the water reuse experts, I tend to look at the Israelis and those living in desert environments that reclaim a lot of water. I know the Korean peninsula has also done the same. So adapting what they've learned or questioning what they've learned and how adaptable it is to our environment and what we can do, I think we can save a lot of time.
Yeah, that's great. We should always be trying to learn from others, right? Don't reinvent the wheel, but try to use our collective knowledge and build upon it. Any other comments or any other recommendations for reuse? Go ahead, Jane, please.
Yeah, and I would also say, kind of going back to this theme of like, what's the source of your pathogens, that there probably are maybe some areas where your rainwater harvesting is being done, maybe it's a large industrial roof or something like that that doesn't have a lot of canopy cover, maybe lower loading from birds, like that might have one level of risk. And then if you're, if you were doing some sort of rainwater or harvesting that included runoff from the ground, that would be a different situation. And I think most of what you're talking about is roof top collection, but that's not always the case. So I think that some of those factors probably play into risk as well, kind of going back to the site specific and transferability of information topic too.
Right, and some of it again is just being aware that pathogens, bacteria could be an issue if you want to do a reuse system or rainwater harvesting. So just thinking about the sources and what are the potential impacts, and that even if you take samples at a certain time and don't find anything, that doesn't mean that's always going to be the case, right? So, well then what I'd like to do before we close, we're going to close in just a couple minutes, but one kind of last question. I want to zoom out kind of at the big picture, 10,000 foot level. And I want to think about this at the big policy, TMDL, attainability level. And think about, we need to make some progress here. And how can we attain clean water and achieve our TMDLs that are being set in place and complete our implementation plans? But there may be some big revisions that need to happen in terms of policy and considerations and metrics and all of this. And so the question is, in what forums should some of these discussions happen? Is this a local level? Is this a state level? Is this a national level? Is it all of the above? And who should really be leading this type of effort to engage these conversations and make some big changes? Is this something that the state should be responsible for? Is it a national organization that should be, or federal organization that should be responsible? Or again, is it something like local communities, like we have in Minnesota? There are some task forces and groups that are multi-agency, multi-disciplinary agencies looking at specifically this issue of bacteria and pathogens and TMDLs. So I'm very curious about your example or your recommendations for this, because we have representatives here from consultants, state agencies, universities, also those that are representing local MS4s and watershed districts and things like that. So we have a very broad range of perspectives. I'd like to hear what you think about how we can really drive this forward through these engagements and policy changes and make big differences. And it's kind of a loaded question potentially, because you can say, well, they should do it. No, you should do it. All right. Go ahead, Jane. Why don't you start?
Yeah, well, first of all, I would say that I think that people involved in this conversation should come from multidisciplinary backgrounds. I think that having microbiologists and epidemiologists there, those people need to be part of the conversation. I think engineers and scientists and, you know, local government folks need to be part of that. So I think it's a multidisciplinary discussion, first of all. I think that, you know, ultimately there's some constraints within the Clean Water Act related to the TMDL program that may require discussion at the, you know, EPA headquarters level. But meanwhile, I think, you know, pragmatic conversations at the state level are also really important, that include both regulators and the regulated community. And I think also maybe creative solutions, you know, what flexibilities are possible within the existing TMDL program, you know, like, are there things that can be done that result in more pragmatic goals under TMDLs that give some flexibility there within the systems that we have, because it can be hard to change, you know, the legally binding regulations.
Other suggestions or other comments? Anita, go ahead.
Well, I would agree with Jane. I think it really is an all level sort of thing. Like as you say, there might be constraints on the top end. I know on the reuse side, we've been trying to do a big effort, interagency effort and a stakeholder effort, and that's going to be ongoing now soon, hopefully. A little delayed to various things, but really trying to get everybody involved. And, you know, it's a little complicated. I mean, we said we've got a bunch of people represented here, and there's so many people involved just even trying to organize that and get all that information and expertise. But I think collaboration is important, and part of it's, you know, when we think about comparing it to other areas, you know, some of it is what risk are we willing to take? And, you know, Jane referred to the EPA standard allows for 36 illnesses and 1,000 swimmers. And so a conversation we've been trying to have, and it's just really hard, is, you know, what is that acceptable risk for various, is that a good risk for us, or are we willing to accept more or less, just, you know, depending on all the other competing needs for water and that sort of thing. So I would say all levels, and appreciate this conversation, and just keep having conversations everywhere we can.
Yeah, and I'd like to also, you know, give a cheer for the Department of Health, because, you know, sometimes assigning the risk and assigning the illness to a specific event is often difficult to do. So it's not just a simple task. And that's especially true of gastrointestinal illnesses, where everyone blames the supper they ate last night or the beach they went to, and there's a lot of causes of the illnesses. So getting all those people together to properly decide on the risk, and the assignment of risk to a certain event is really important. And I'm glad I don't have to do it myself.
Right? No one person can do it all, right? Go ahead, Diane.
Yeah, and I think, as I mentioned earlier, there's a lot of parallel with the chloride issue, in that if you'll recall that the MPCA, the Pollution Control Agency, convened a multi-stakeholder task force to really review the standard, and also ultimately came up with a winter maintenance tool that incorporated a lot of best management practices. And then the latest draft of the general permit, stormwater permit, does include provisions for MS4s to use that winter maintenance tool to demonstrate their compliance with those BMPs as a way of demonstrating their compliance with the metro-wide chloride TMDL.
Yeah, that's a great idea of identifying that parallel and trying to learn from other examples, even if it's not specifically pathogen bacteria. So what I'd like to do now, we're going to close. What I'd like to do is give each of our panelists a chance to give us their key takeaways from all of this discussion. So panelists, we're going to go through the panelists, and we're going to let Jane have the last word. Please tell us what you would recommend from all of this that we take away, that we can use to do next. What do we do next? What are your recommendations? What are your suggestions? So we're going to start in the same order that we introduced each other. So Anita, please go first.
Well, I guess I always like to put in a public plug for thinking about public health and all that we do. And again, so I appreciate this conversation on pathogens. I know it's a tough issue to resolve. And so again, I appreciate all the work that's happening in this arena. I think we can do a lot, as we've talked about, with some of the basics of, source control, looking around, things that, common sense don't look good. Let's fix those first. Committing to the operation, maybe having to go to a little bit more of an active, both operation and observation of these things, committing to the maintenance, and not necessarily the expensive monitoring, but just some base level monitoring, so that a lot of times if we can just notice changes, those are the times we need to watch out for. And so committing to some of that, and then finally, we do want stormwater to be a resource, and we also want to be protective of public health, and so we just want to support all this further study and answer these resource questions while still trying to act on those things that we do know now.
That's great, Anita. Mike, what would you recommend as our key takeaways from today?
I think what I mentioned before about keeping your eyes open and really using your knowledge of the area, the potential input sources that might be there, and what might be causing the TMDLs initially to be exceeded before you investigate money in expensive testing.
That's great. Thanks, Mike. Diane, what would you recommend what would you give as key takeaways from this?
Well, I think that I don't have a lot to add to the other comments, but I did want to offer kind of a comment similar to what we do with other TMDLs, which is don't get so fixated on your waste load reduction. What you're really trying to do is improve the resource. And again, it is focusing on just common sense alternatives that are out there, and do what you can and understand and accept the fact that it's going to take a long time.
All right. Yeah. All right, Jane, give us the last word. What would you recommend as key takeaways?
Well, I think I'll just say I agree with all of the takeaways that have been expressed. And I would conclude, I think, with a kind of a shameless plug for those of you that are doing BMP monitoring and research to share your data with the BMP Database Project, so that people around the country and around the world really can learn from your work.
That's great. So with that, I would like to thank all of our panelists and, of course, our invited speaker, Jane Clary, for setting up this discussion and contributing to it. I obviously want to thank all of our audience members. Thank you for joining us today. If you are watching on YouTube, thank you for finding us there and viewing this. With that, we will close the webinar today, and thank you again. If you're interested in professional development hours, you can contact me, Andy Erickson, directly. So with that, thank you so much.